Please welcome Gumsticks.
Thank you. Actually, can I just, is it okay to sit down on a chair? It's just going to be a lot easier.
Forward arrow going to go slide.
Perfect. Sorry.
That's fine, sorry.
There we go. So, I apologize if you've seen some of this slide before. My name is Gordon Kruberg. I'm the founder and CEO of Gumsticks. Craig Hughes is here. He's the co-founder and chief technology officer. And I don't know how many of you have ever heard of Gumsticks before. In a nutshell, what we do, we sell a platform. It's a tiny little platform. It's roughly the size of a stick of gum, 20 millimeters by 80 millimeters. So if you're used to PC-104, I mean, this is much smaller. We are a tiny, low-cost, and complete system on that 20 by 80 form factor, founded in order to do ubiquitous computing. Ubiquitous computing. By ubiquitous, I mean truly a computer small enough that you wouldn't know it's there. We could have gone for something smaller than 20 by 80, but we decided that if that wasn't good enough, then no one's really going to care in any case. It's a fully open source model. Every piece of software that we put on there is open source. And it's expandable. We publish all the daughter card schematics, so anybody who wants to knock off a daughter card and build it for themselves or do a derivative piece of work is published under the Creative Commons share and share alike, as well as shared attribution share alike license, so that you can do whatever you want with it. We use Eagle CAD as the software package to do derivative daughter cards. That's us in a nutshell. My background was a venture capitalist for many years, and have been CEO or co-founder of School Pop, ran a company called Novariant for a while, and then Craig and I did Deersoft together. Craig's background is in software optimizing the shopping experience, and you can tell a little bit of Panopticon, and then Deersoft was Spam Assassin with me. Don Anderson is our Chief Marketing Officer. He's based in Canada, and he and I have worked together in the past with Voice Mobility and then Deersoft. What we make, here's a picture of one of our motherboards. This is one, as it says down there, with Infineon Bluetooth module on board. It's a small, efficient, sub 1 watt, 400 megahertz computer, low cost. To get up and running on this, I can't remember the student pack is, if that's a $99 or $129 cost in order to get up and running with your own Linux environment. And then we're up to date on kernel. Craig's got 2.6.20 out right now, right? And then the full GPL development toolset. What it does, people use this in network appliances, they use it in telephony applications. We have an activity in cell network monitoring services, not monitoring cell network, but actually monitoring stuff by using cell network. Industrial design projects, and then education and robotics fits into one category for us. And I'm going to walk through real quickly some examples, and then Craig is going to go through something that his own little project that he's done with the Gumsticks, which is kind of cool. So in the examples I'm going to go through are in network computing, remote data servers, so not just monitoring, but actually serving data, managing data and serving it up. Rapid prototyping of distributed appliances, and you'll see a few of those, and then some robotic applications. One of our big customers uses, what you're looking at is a wall mount RFID swipe device that is networked either by 100 base T or 802.11g. And this runs an SAP client, and so throughout a number of their customers, when somebody goes to work and logs in, that asset, that individual is logged into the SAP system. This is, yeah, touch clock, yeah. Network computing, IP telephony, everyone here knows about IP telephony. That's an asterisk server on the, so you can see the Red Bull. And this here is the Gumsticks, but this is, full PBX capable of handling 40 simultaneous calls. Cell data services, there's a company in France that uses this, and they do remote gas metering. So in an apartment building in France, the custom is that the apartment owner is responsible for the utilities, and what these guys are able to do is to put utilities management per tenant and then bill out using the system that they built on top of the Gumsticks. And they monitor over the cell system. This is kind of a cool one. I don't know if you've seen e-ink. It's e-ink technology. Every e-ink prototype system ships with the Gumsticks. E-ink's a partner of Philips. Philips got a subsidiary called Polymer Vision, and this is their Radius. And if you look at where that person's thumb is, you would, as a Gumsticks user, you might notice that that's roughly the size of a Gumsticks. Well, in fact, that is the Gumsticks motherboard for the Polymer Vision PDA. There's a group locally that's doing an open cell phone, and within the next 3 months we will have an open cell phone available. We're working on screen and battery right now. We'd like to use a nickel metal hydride battery, so it'll be a little heavier than somebody using a lithium polymer. But we're concerned particularly about our customer base and having lithium polymer in the hands of hobbyists, because it still blows up every once in a while. You do the wrong thing. Nickel metal hydride, I've shorted out, and I haven't blown one up yet.
Isn't there, have you heard of Open Moco? Are those the same people?
No, the OpenMoco guys are a little bit different. They're the open cell phone guys are more about you being able to build and customize your own hardware and the software. OpenMoco sells you a complete hardware.
It's a phone.
Yeah. Right? It's a phone that has a lot of open software on it.
Right.
So the two are working together, so that OpenMoco software should be able to run on this stuff.
Yeah.
But it's a little bit of a different emphasis.
OpenMoco actually is a Linux phone, but the only difference I think is they added something extra that to enable you to flash it yourself.
Mm-hmm.
You can flash Nokia phones, but you have to have a special cable, and their firmware isn't Linux to begin with, so you really can't change it much.
So what open cell phone is, it is a build-it-yourself homebrew phone. So it's a lot of flexibility for somebody who's of the homebrew. TolerCam, so we only support Linux, but one day, actually the day after Windows CE 6.0 released, I got a phone call congratulating me on being in the launch. Turns out that there is they call it shared source in the Windows world instead of open source. There's a shared source project called Drumsticks that has ported WinCE to the Gumsticks, and when Microsoft launched the 6.0, they gave a nice little speech about Gumsticks and how you can use WinCE on Gumsticks. So it's kind of cool. One of the users, a guy named David Vescovi, is down in Florida. He won a project. So what you can see here is a camera at the back of his little SUV looking out behind, and it's broadcasting, I think over Bluetooth, to his cell phone in his car that he can look at the screen. So this screen on his cell phone in his car is getting Bluetooth images from this camera that's looking out behind, so that as he backs up, he can look at his cell phone and see what's behind him. Everyone, does anyone here have a Roomba? Have you built something onto it yet? So Roombas, this is a project from a guy at MIT. They make some
Projector.
So you can see the shape of the Roomba in any case, and here's a little Gumsticks with Wi-Fi, and what this guy's done is built an 802.11g interface to his Roomba so he can control his Roomba when he's not there. There are a lot of projects that we're investing in this. And here is a stack. I'm not sure if this is this stack right here. I think it is.
Yeah.
Or what he's done is, I think that this is the power. He's got the gum sticks here, a daughter card, and then actually this is our daughter card on our gum sticks onto his card. That's what it looks. CF interface so that he can use an 802.11. This is back before we actually had a daughter card for Wi-Fi. And then this controls directly into the under the Roomba. It's tall, you know, 1.5 inches tall, but it's.
Do you support SDIO?
SDIO is now in the Linux kernel.
So our hardware has always done SDIO, but there hasn't been an open source SDIO stack until like the last month or two. The SD organization recently loosened up their spec. It used to be that if you were a member of the SDIO organization, you were basically forbidden from writing any open source code. And they've loosened that up so that it has now enabled SDIO drivers for Linux.
There are quite a few SDIO Wi-Fi cards. Some of them are actually quite
So
good.
that is
low power.
Yeah, that has just started happening in the last 2 months that those have been available under Linux, because until then you basically couldn't have an open source SDIO stack.
I'm dying to try one because our basics, the original basics, is always supported it.
In hardware.
In
not
hardware, yeah. Land robotics. So there's all the different robotics. Just so kind of a historical note. I started this because I wanted to do robotics. I wanted something that I could put onto a robotic member. So these guys at Simon Fraser have got a swarm, and you can see this. You can see that this is this is 80 millimeters here. This is about 100 millimeters by 100. So these are pretty small swarm robots. There's a group of guys in the UK who have built social tapestries. It is, but it's. The concept is feral data collection. So they send these little things out into into London, and you can see this one's doing GPS tracking and logging in. It collects data. I forgot what the data is. This air quality in this one of what's going on throughout. But instead of a coordinated effort of managing all these different robots, they let them free. They've got these quote-unquote feral robots that are out there tracking data. Next, George Mason has been a great university for supporting us in an open way. They have done a lot of work, and you can go to GMU and see, yes?
Since we don't have to torture people with the smell of pizza,
Okay.
so why don't we take a 5-minute break
Great, okay.
and let people get some food?
The Wi-Fi card.
Once you're infected.
Okay. So GMU, as I was saying, has got this Flockbot project. And you can see on here, they've taken away small, made some modifications. And each one of these has got a little way small on it. That's the brain, driving all these things. Pretty cool stuff. And they've published everything. They've got a wiki that you can go to.
Each robot in the flock communicates with the other robots by Bluetooth.
Do people ever steal them? Like, hey, it's a free hardware in these. Do they ever disappear? I don't think you could do that in New York City or well.
Disappear.
Oh, you're talking about the London, the social.
The feral robots, you mean?
Yeah.
I have no idea.
I don't know. They
If
probably.
someone walking along the scene with those, they could easily make off with it.
Yeah, I'm sure that they monitor them. They probably just call them feral, but I'm sure that they.
If you can't sell it in a bar for $20, they're not going to rip it.
One of my favorite projects is this fellow in Cambridge who put a helium weather balloon together with a cell phone, 2 cameras, and a GPS unit, and floated it. Went up to 65,000 feet, traveled about 63 miles. Then deployed the parachute, came on down, and when it got back into cell range, it called them and told them it's an SMS
Sent a
message.
text
a
message
lot
with GPS
yeah.
coordinates.
Great, that was one of the earlier projects. Really, really neat work. Another English project is, you can see the helicopter, you can see the Bluetooth antenna sticking down.
I've seen that
It's
before.
broadcasting over here, and it's being controlled so the primary avionics are here, but they're being guided by a window right here. Don't know these guys. These guys came up on a search of where Gumsticks was being used. I don't know exactly where they're being used in this project. This is another UAV at Stanford. In France, another UAV being done. The thing weighs 8 grams, so in terms of wanting to put some good compute power on it as something that's going aloft, it's got the power of weight ratio. And then underwater, the University of Vermont has put this together, and the reason actually is, I don't know if we've got this online. We should probably publish this presentation. It's got links to all the, many of these, not all of them have them, but GMU's got one, Social Tapestries has got one.
Will we be able to get a copy of this?
Yeah, there's what I'm thinking, we should just put it up
Yeah, we'll put it on
online.
our website and we'll send you the URL.
And then Vermont's got, they published the instructions on how to build what they have built. And then this is one that Craig referred to at the very beginning, and I think this is my last image. And do I get to say play here? Will this work? Okay. There we go. Now I'm going to stand back.
For pesticides inside, actually try to pump into water or get rid of the water and try to control
Okay, so
it.
when they pump the water out, the fish rises, and when they pump it back in, it
Right.
goes down.
Yes,
I think-
yes, simple
But
as.
they seem though
That's
they're
a robotic
quite
fish that you
they
just
seem
saw
to be bumping into the
swimming
water all the
around
time.
in
How
the
do you
tank.
manage to do that?
We have the
And it-
different
Gumsticks
sensors
is the
as said,
primary
because
controller.
we have infrared sensors on board, and they actually detect the distance from the object. They can avoid other fish, they can avoid wall and any obstacle.
Well, they're very clever. I know you've got 3 different fish there. How do they differ?
They also have some kind of learning ability as well to change their behavior according to the experience they have in the tank.
Can you give me an example?
For example, if the fish is continuously dumping into the corner and they realize, okay, this is the dead end, that they should be very careful. In this case, they should be sharp turning to avoid it.
And what is the difference in their personalities?
And at different stages, because each fish move in different way, they may get different experience. So eventually they have different experience and different pattern of the reaction. So this is actually built up incremental. So we cannot control it. But so that demonstrates that eventually a fish has different personality.
Now, apart from just being fantastic in their own right, what are you hoping to do with them?
It has many real-world potential applications, such like seabed exploration, and also oil pipeline leak detection, and also we can actually do some investigation on the sea life, especially deep sea life.
Sounds fantastic. What has been the reaction from the public there?
Oh, that's a marvelous reaction from the public. Many of the audience and the visitors cannot believe their eyes because they thought this is real fish, not like robotic fish.
Well, they really are wonderful. Thank you very much for telling me a bit more about them. I appreciate that, Dr. Hu.
It's my pleasure.
I've been talking to Dr. Hoshan Hu, the creator of the robotic fish, and he joined me today from the London Aquarium.
Great. So that's what they do. So people, for years, people have been saying, so it's small, so what can you do with it? What's so special about a small computer? And it's a fair question. And now I can point back and say, well, these are all the things you can do when you have a really, really small and computationally powerful computer that doesn't draw a lot of power. Now I'm going to switch over to Craig. Craig does all the software, and after the very first effort by me, I guess. And Craig's responsible for putting together what I think is an amazing development kit for this, that we nonetheless give away for free. So I'll let him talk about something that he's done with his own little gum sticks.
So let me talk a little bit about the software that's on the gum sticks. I mean, you've seen sort of 1,000 examples that Gordon just went through of what people use them for. But obviously, you guys are Linux people. That's why it's called Linux user group. So every single one, well, there was that Windows CE one, but most of those devices are actually running Linux on the gum sticks. And it's not stripped down Linux or restricted Linux or anything. It's just full-blown Linux that's pretty much identical to Linux that you have on your desktop PC. The software that comes on the gum sticks includes a full-blown Linux kernel, all the standard user space tools like LS and CP and all that stuff, a shell, an SSH daemon, a web server, DHCP client, basically all the normal stuff that you have. It doesn't have stuff like OpenOffice and things like that, obviously, because it's a fairly small restricted device. You can do things like web browsers and stuff. If you take off the web server, you put on a web browser and that kind of thing. But a lot of those kinds of applications would depend on what kind of screen you connected to it and that sort of thing. So you can customize it and you can do whatever you want to. Any Linux application will run on it if you have enough RAM and storage space or whatever to do it, or if you NFS mount on a really large file system, you can access as much storage as you really want to from the gum sticks.
Is it real-time kernel?
Yeah, I've got all the real-time extensions merged into 2.6.20 running on this thing, so yes.
Preemptive scheduling and all that.
Yep. So I thought I'd just kind of go through and give a more concrete example of actually interacting with Linux running on some device that's a gum sticks thing. And so this is an example that I did a couple of years ago actually now. I got rid of my home phone line and I only have a voice over IP phone line, so I have a broadband connection cable modem and I have a Vonage telephone. And modems really don't work very well over voice over IP because the basically what the modem wants to do is assume that there's an analog piece of copper wire there so they can do signaling. And the encryption stuff and packetizing that voice over IP modems do basically doesn't cooperate well with the signaling that the modem wants to do. So you can run a really, really, really slow modem connection over a voice over IP link. But I've got a broadband connection anyway, so I figured, well, what might be a better idea is actually try and bypass the fact that it wants to have a modem there. This is kind of what I did to wireless enable. Now, the other thing I wanted to do is not actually have a wire coming out of my TiVo going into a phone socket or a Ethernet socket in the wall. I wanted it to just be wireless. Obviously, there are cables connecting the TiVo to the TV and connecting the TiVo to the power, but I didn't want another cable. So the TiVo Series 1 is fairly unexpandable. I think Series 2 and now Series 3, they have USB on there, so you can plug in Wi-Fi and Ethernet controllers and that kind of stuff. But I didn't want to pay another $500 to get a new TiVo. The one I have works just fine. And so I needed a way to basically pretend to be a modem. So the TiVo wants a modem, wants to make a daily phone call using a modem over a phone line. There isn't really an easy way to add Ethernet. You can break open the case and like plug, hack in an Ethernet thing, but it's not all that easy on the Series 1. And you really can't actually add Wi-Fi. It doesn't have any easy way of doing that on the Series 1. But it does have this facility to use an external modem. So the TiVo has a built-in modem, but it also has a facility to use an external modem. And has a little serial port on the back of the TiVo. So I thought, okay, I'll use that. And then I'll take the gum sticks and have the gum sticks pretend to be a modem and have the gum sticks then forward all of the modem stuff through Wi-Fi onto my home network and then out onto the internet. So Series 1 PVR luckily includes a serial cable for their little weird serial port that they have on there. And then Gumsticks, I'm just using a Connect 200XM, which is kind of a bottom of the line Gumsticks. It's a 200 megahertz processor and 64 megs of RAM and 16 megs of flash. The 16 meg, by the way, all that stuff that I was talking about that comes on the Gumsticks, Linux, web server, shell, user space stuff, SSH, daemon, all the rest of that stuff takes about 3 megs of that 16 megs of flash. It's a compressing file system, so it really makes pretty good use of that. So you can have quite a lot of stuff actually on 16 megs of flash. Then I've got a Wasteful Stewart daughter card, which basically has a serial port on it with a little connector that you can plug a cable into. The Gumsticks itself has 2 connectors on it that are kind of tiny little pitch connectors that are basically designed to connect to our daughter cards, but you can't really connect them directly to outside systems. So the function of the daughter cards is basically connect to one of those or the other of those connectors that are on the motherboard, and then do some fairly simple logic, that's normally level shifting or encoding or decoding some signal, and then bring it out to a standard connector like an RJ45 or a serial port or some, whatever it is that brings it out. So I have a Wasteful Stewart, which brings out a serial port, and then I have a Wi-Fi sticks, which sits on the other connector on the Gumsticks, and it has integrated Wi-Fi 802.11g. So that is the Gumstick sandwich. I'm usually, let's see, kind of like cursor going here. No. So what you're looking at here on the top is actually the Wi-Fi card. This is the little Wi-Fi module. You can see the antenna coming off there. If you can see, there's actually another little board just behind that one, which is the Gumsticks motherboard. And then this big one behind there is the Wasteful Stewart, and the serial port is coming out over here. That's the serial cable. This is power coming out this way. So that's the device. And this is a standard mini DIN connector, so you can get a sense of the scale from that. This is a mini USB connector, if you're familiar with those. So that's the Gumstick side. This is the TiVo side. They have this 3.5 millimeter jack in here that is what their serial port comes out of. So this cable here comes with the TiVo, and it's basically the other side of this cable. So the Gumstick plugs into the TiVo serial line. There's a way that you can configure the TiVo to use an external modem instead of its internal modem, which is documented in various places on the web under, if you Google hack TiVo modem, it will tell you how to do that. You can see my phone line is actually unplugged here. So then, that's the hardware setup, and then on the software side, obviously I've got Linux running on there, but then I've got PPPD running on the Gumsticks, basically pretending to be the modem on the other side. So when the TiVo tries to make its call, it then is going to try and initiate PPP over that, what it thinks is a modem link, and it's going to think that it's talking to the TiVo modem pool on the other end, but it's actually talking to PPPD running on my Gumsticks instead. Then I'm going to run IP tables on the Gumsticks to just do network address translation. So when the TiVo establishes that PPP connection to the Gumsticks will then forward any packets that it sends to the internet. And it turns out that the TiVo modem pool actually just connects into TiVo, but all that stuff is accessible over the internet. So if you get the connection established, the TiVo will just merely request the stuff, the packet, the stuff will go over the internet and will come back. Yeah.
I'm a little unclear on why is it that you need NAT for this? I mean, you've only got the one wireless interface on one side and the one serial on the other side. So why don't you just NAT it straight?
Because the TiVo is getting an IP address from PPP, which is on that PPP link.
Yeah.
So you'll see it when the script comes up later, but basically I've got a 10.0 network that is that PPP link, with an IP address for the Gumsticks and an IP address for the TiVo on that link.
I guess I would have probably just turned routing on in the kernel.
But then I'd need a publicly addressable IP address for both the TiVo and the Gumstick side of that link.
Whatever, go ahead.
I'm trying to think if there is a way of doing it just routing. I don't think there is, because
You have to run IP rating, right?
Yeah, right. So because I think the PPP link between the TiVo and the Gumstick is not a publicly addressable link. So when the TiVo makes requests for internet things, in order to do the routing, you have to do network translation.
Never mind, NAT will work. That's probably a more complicated way to do it.
Okay. And then I need a couple start scripts to basically, when the TiVo boots up, I don't want to have to log in and get this stuff going, so I just have a start script to start up PPP and IP tables. So this is the start script, which is basically pretty much all I had to add to the Gumstix out of the box to get this working. You see it's just a couple simple lines. The first thing I do is turn on packet forwarding. Then I just set up the IP tables from a saved file, so I just have all the stuff in there. I'll show what the contents of that file are. That's really pretty straightforward too. And then I run PPPD. So PPPD is running on one of my serial ports on the Gumstix at 115.200, and then all this other stuff just basically says, compress it and make sure that the connection comes up when the TiVo tries to dial, and don't require a password, and restart yourself when you die, and all the other options you have to pass PPP. But this part down here is basically setting up the network addresses for, I think this is Gumstix and TiVo, but it might be TiVo and Gumstix. And then that is the IP tables, that's this IP tables file here. Basically, there's exactly one rule in it, which is in the NAT table, add to post routing that anything that's trying to go out by MWLAN 0, which is the Wi-Fi link, aspirate it. And then what happens? Well, when the TiVo tries to make its daily call, actually, so this is the Gumstix booting back up here, and then 10 minutes later the TiVo tries to make its call. So you'll see it basically starts up, it starts listening, and then right here it actually connects. So I guess the Gumstix is .1 and the TiVo is .2, and then it actually is transmitting data then for about 25 seconds back and forth. Connect time, half a minute according to PPP, and then it tells me that the TiVo sent 200K, received 20K. So this is the program guide information, what shows are on at what times, it's getting that update from network. And this 205K is the TiVo spying on me and saying, he pressed fast forward at 1,300 hours and 5 minutes and 12 seconds while he was watching Veronica Mars, and then pause it while whatever was going, all that information TiVo uploads every day. So one of the things that it was actually interesting to notice as I did this, that this is like 10 times that, and that's true like every day. That was kind of an interesting thing to notice. And it's probably, this is being compressed too, and that's probably not being compressed as well. But I've tried looking at what this data is by, snooping the network connection and stuff, and it's all encrypted, so you can actually see what's going on. So that's basically it. But that kind of gives an example of sort of how simple it is to build what seems like a fairly complex application on a Gumstix. It's just really simple because of the fact you've got Linux on there doing all the heavy lifting for you. And pretty much, most things you want to do will be like a 10-line shell script to read from one port right to another one. It's all just Linux and totally straightforward networking. Everything's just the same as you're used to on a desktop box. So that's it. Oh, actually, there was one other thing I was going to do, which is turn this off.
This is a screen of,
Sorry?
this is the Gumstix.
What you're looking at here? No, this is a Mac laptop.
It's not X Windows, there's a mini X Windows, tiny X. A lot of guys.
Yeah, you can run X on a Gumstix.
And V and C.
Okay, let me do this now.
You going online through the software?
Yeah. And then I have a little. I'm actually going to log into my TiVo sticks at home here. Oops. Assuming my cell phone link is actually working. What is my cell phone? Oh, yeah, it's definitely working. Ah, there you go. There we go. So I'm now logged into my home thing. I set up port forwarding before I left on my cable modem router. But you can see I'm logged in. I've got all the usual Linux stuff. So that script, that startup script, is just this.
What's bonjour?
That is the network advertisement thing that Apple does.
Yeah.
It used to be called Rendezvous, now it's called Bonjour because it got sued by, I think, Tivoli owned the trademark Rendezvous. Tivoli. It's a network messaging middleware application. So this is my startup script that just starts it up. I just extracted the start part, but this is the full thing where it kills PPD and shuts down and stuff. Let's see here, it's pretty miserable. Yeah, that's what I get for trying to SSH over a cell phone. I mean, you can see it's just a, that's user bin. It's just got all the usual stuff in it. Oh, and there's another thing I can do too, which is
DF-H.
Sorry?
DF-H.
Yeah.
What distribution are you basing this on?
It's basically, it's not, you can't really use a standard distribution because you're so restricted in what you want to do. You really want to get down to controlling everything that's on there. So I have, that's proxy view info. So here I've got 16 megs, 4.3, which this is actually a 400 megahertz one. I thought it was 200, but you can use 200 just fine for it.
That's vocal MIPS though, it's not real megahertz.
Yeah, but on this CPU, it actually corresponds pretty closely to one.
The official, it is 399 point something megahertz.
Yeah.
So it corresponds very.
Basically, the VogaMIPS loop, when you implement an ARM assembly, executes about one instruction per cycle. So it ends up coming out being almost exactly the same thing.
So I gather from that means you don't actually have hardware floating point in there, right?
There's no hardware floating point on GUM6, that's correct.
That has to do with Xscale. They don't have.
Yeah, the Xscale doesn't have a floating point. We are looking at floating point stuff for a future generation of GUM6.
Is the move of the Xscale stuff to Marvell making any?
Yeah, it's
Probably.
a giant pain in the neck. Intel love to give out all their documentation. They just post it on the website. You download any documentation you want anytime you want. You don't even have to be a customer. Marvell wants you to be a customer, sign an NDA, give them your firstborn child, and then maybe they'll let you look at some of the documents.
Including GPL code.
Yeah, including GPL code. They have a lot of code that they publish under the GPL that you need to do all of that above mentioned stuff in order to get the code for it.
I talked to somebody today who signed a Microsoft NDA. It was one page.
The NDA.
Yeah.
Just says you will not, period, sign it.
Do you know much about the vocal MIPS under Intel, i686?
With benchmark, you know the benchmark numbers, this corresponds pretty closely to,
It's about a 350 megahertz Pentium class CPU at 400. So the 400 is about equivalent to like slightly less than a 350-ish.
Because at work I use
Except floating
QEMU.
point.
At work I use QEMU to do emulation for people, like a lot of the engineers want to run XP to run Word or Visio or something. And they're like, oh, it's too slow, but I can see the VogaMIPS is like 3,600, and I'd like to be able to tell them.
VogaMIPS is a very bad measure of performance because it's a very tight loop that's just basically spinning in a loop, and then it counts how long it takes to go through a certain number, or how many iterations it goes through a certain amount of time. And so most interpreters or emulators like QEMU will just compile that loop, and so they'll run the loop really, really fast, but it's the actual compiling of the loop that slows things down. So if you have bigger chunks of code running under QEMU, they'll go a lot slower than a loop that's like 3 instructions long.
Of course, the real CPU has its own problems if that loop is all inside a cache.
Right, exactly. And by the time you've added the overhead of running in the emulator, then it's blowing out your cache even more.
Do you know what VogaMIPS is used for?
It's just it's really not. I saw something that what's his name?
Linus came up with it. If there's-
I don't think Linus came up with it. I think it was actually, what's his name? Ray, who's the Linux Bazaar guy?
Oh, I know where it is.
ESR, yeah. Eric Raymond, right. So Eric Raymond, I think, actually wrote Bogomix in the first place. And there's if you do a search for Bogomix and Eric Raymond, you'll see what his comment was, which is Bogomix is entirely useless for measuring anything. But it's basically, the point of it is to establish how many clock cycles there are in a jiffy in the kernel or something. I forget exactly what
It does serve a purpose. I know that it does actually.
Yeah, but if you're comparing two machines, Bogomix is not a useful way of comparing. Yeah.
Could you talk a little bit about how it does, how you do input-output type operations at different layers? Because I've seen you list some analog digital boards.
Yeah.
But
So,
like, what's
okay.
the layers in which you can kind of get to it?
Yeah, I can talk about that a little bit.
Because rather than just writing assembly code with poke numbers in a location, I'm sure there's a better way to do it.
There is. So let me
Use Linux. So
I can show you in a second here if this opens back.
be proud of something that Craig did. He wrote a prop driver for GPIO so that actually
Yeah. So the PXA has 84 GPIO lines, which are configurable to be either just straight digital GPIOs on or off that are software controllable, or you can overload the functionality to be, say, a serial port or any of the sort of major functions that are on that system on chip. So I wrote a /proc driver, which basically allows you to configure the alternate functionality of each of those GPIO lines. And if it's in GPIO mode, turn the line off or on, or if you're at GPIO input, read whether the level is high or low. By just echoing to, you can just say echo clear to /proc GPIO 99, and it will turn that line off.
Well, how do those, there's two analog digital converter
Yeah,
cards listed right now.
Yep. So for those two cards are actually a little bit different. One of them, the A to Ds are on the Atmega 120 or Atmega 128 microprocessor that's on the RoboStix daughter card. And so in order to read and write those, you either have to write Atmega assembly code or Atmega code, you write C code to process those AVs. But I think that some of our users have actually already written basically a library interface to that, so you can write fairly high-level C code to just read from AV.
I thought Highlands had done a
I think he's done something. Yeah, I think he's actually also done something where if you have a RoboStix connected to a Gumstix, that you can write high-level C code on the Gumstix, and it abstracts away the communication between the Gumstix and the Atmega and the code running on the Atmega that should be done.
Where I kind of run into where I lost track of what, if I was reading about it, was I wanted to understand what's the performance of those analog digital converters, is like instrumentation or audio or?
The one on the audio sticks is designed to basically do two things. One is audio, obviously, and the other is touchscreen stuff. So read positions on the touchscreen, which are analog signals. I think the resolution and voltage range for both of them, I think, is available somewhere on our website. I don't remember off the top of my head, but I think it's like 7.5 volts on the audio sticks at 16 bits, and the Atmega 128 ones, I don't remember. I think there are two different kinds.
I've forgotten entirely.
Yeah, I don't remember at all.
Where I ran out, I was looking for, if I was going to connect some instrumentation to Gumstix,
What kind of instrumentation it ends up, the core question ends up being, because there are ways to get data in the 1 megahertz range and on the Gumstix if it's not analog. I mean, if you want to do a GPIO measurement, you do it at the 1 megahertz. The RoboStix is 100 kilohertz, I mean, again, if you could quickly but when it gets down to serious instrumentation, you run into how fast is the A to D and how real time is the kernel.
I've got a notion of like it's a controller for a solar water heater. and it's still got some in it.
Yeah, so, yeah, I mean, there you
So
go,
that is
once an hour.
so there's actually, there is a company that's building a solar control system using the gun sticks for all instrumentation. It's being used as primary avionics on a lot of UAVs right now.
Yeah.
So that's got a whole range of different kinds of instrumentation and.
Yeah, and the modeling of how, easy ways to do output without trashing the gun sticks, without inadvertent.
So I was talking about this earlier today with somebody who's trying to sell us optical coupling. So we do some optical isolation on some GPIOs, and we keep talking. We've had 3 daughter cards on the list of this would be fun for 3 years. Bread sticks, which would be a breadboard attached with a placeable gum sticks attached across the top, so you could have access to all the GPIO on a breadboard. Dipsticks, which is gum sticks with a dip package that you put it down. Dipsticks, breadsticks, and proto sticks, which is kind of a blend of the two, where it's a prototype board that you can attach it to.
Well, yeah, my experience was from basic stamps on the development board.
Right.
Which is
Right.
the same, I'm just going through the same problems of looking at the thermistors, switching some relays, and feeling safe. So we'll controller, do some calculations, and then if I understand Bluetooth,
Yeah.
appears to be that's the whole transport layer from electrical all the way up to the software, and I just plug in some Bluetooth receiver on my Linux box, and then I'm
Yes.
receiving everything I want to hear about my little controller.
Yes. Kind of. But yes. As far as I can tell, yes.
Yeah.
I don't know exactly how deep your question was, but as far as I'm concerned, you got to be able to turn on a Bluetooth client and server, and they just talk to each other over whatever channel you choose.
Well, I haven't, that level of understanding of Bluetooth is pretty bad. And because I don't know, and IP802.G type wireless communications, that's all, it's always hung up on the protocol. And of course, proprietary drivers, but the Bluetooth sounds like it's not blocked with those old deliberately introduced.
There's so many ways you can communicate between 2 boxes. And the nice thing about the gun stick being one of those boxes is that you've got a full server running on it, and you can choose, you can communicate with it however you choose into a shell. So you can be on your desktop communicating over Bluetooth into a shell, and then do whatever you want on the server, on the gun stick server, and including control all the GPIO, whatever you do. And the other key thing to remember when you're working with the gun sticks is that I think there's no K in gun sticks. When you're working with the basic stamp, it's 32 K instructions per second, right? Gun sticks, it's a 400 megahertz Linux machine with 64 meg of RAM, and it's an extra $30. It's a huge performance improvement. The concept of having to worry about how fast it is on the stamp compared to how many stamps you can emulate on a gun sticks. I mean, they really are orders of magnitude apart.
Yeah, well, my other thought is the first thing that I would do if I had a gun stick would be to have an opto isolator front end. Because 12 and 24 volt solenoid electrical valves, and I hate.
You hate the fried stick. Yeah, happens all the time. But yeah.
Yeah.
If by some miracle you got your hands on one of these polymer vision Redius things, what are the prospects for taking control of its little brain?
I don't know.
Taking control of.
You mean of actually getting into the command line on it and being able to do so? I suspect it's slim. I actually think in the version that they're actually selling in volume, I think it was their prototype out of Gumsticks. I don't know if the final one does.
Yeah, the only one I've heard going to production, Telcom Italia just announced that they're going to do a Linux phone with a Palmer, actually, take that back, it's not a Linux phone, it's going to be, it's a rollable screen phone.
Yeah.
It's not Linux.
It's gonna be,
Telcom Italia,
A rollable screen phone?
yeah.
Yeah,
Oh,
so that's a power vision thing.
What are they gonna run on it?
I don't know. I didn't.
Symbian?
All I know
Probably.
was that it was Palmer Vision and TI. Sorry, Telcom Italia doing the deal, and it looked kind of cool, but you know, it's not using Gumsticks. So.
You know what I found is a lot of times people develop products and then at the last minute they don't put the operating system on. They like I knew a company that used OS 9, which was not the Mac OS 9, but the embedded system OS 9. And then when you bought the product, there was no OS 9 on there. They actually found a way to just take the application and then add extensions to it, so it did all the I/O
Right.
itself.
Yeah, I mean, the core of where we sit in the broad computer community, computer manufacturing community, is we have a lot of functionality that if somebody's going to make multiple millions of a product, there's no way they're going to waste an extra $2 on this connector.
There's
or
$2 million in profit.
yeah,
It
and
makes
so
a difference
as soon as it hits, you know, 1 million units a year, we lose them as a volume customer. But all our customers fall in the
Probably a 50 meg
under
flash thing there too, can install.
under 30,000 units a year category. But up to a 30,000 unit a year user, it doesn't make sense to redesign the motherboard. Redesigning or re-engineering the motherboard is a big piece of work. Re-engineering all our daughter cards, we make simple, really simple. Almost handhold our customers through redoing a daughter card. And those are easy to turn. But there's this limit, and it's somewhere between 30,000 a year and 100,000 a year, where as soon as you hit that limit, it makes sense to design out all the extra pieces.
This unfolds.
Well, I guess one thing that has always been slightly annoying is that for each of the two connector types, you can only have one daughter card.
Yes.
You can't stack them. And then you have to choose.
Well, they
between-
can be stacked if you do your own daughter cards. We don't do any stackable cards at this point.
One.
We have tweener, and that's
Which is a
a schlock product. Yeah. That was something we did internally to solve the problem, and it turned out that everybody wanted
You need to make a hub sticks.
hub sticks. Yeah. Well, there is a what's it? The Gumwad project. There are a few Gumwads out there where they've.
Yeah, I mean, it turns out that the easiest way to connect a lot of this stuff together, if you want multiple of them, is just run an Ethernet backbone. Hang them all off an Ethernet bus. But then, yeah, I guess then you need an Ethernet Gum6 for each one. So that's their
Depends
prototype
on
that
how
they
fast-
actually are now selling to some Italian cell phone company. So the
Depends on how
screen.
fast you have
So
to
they gave up
talk
on the
to them.
rollout, and
Yeah.
it's just a fold out.
I suspect that that's probably a mechanical issue, which is, you know, when it rolls up, you need some kind of spring or something, you know, a coil spring or something to wind it in, and that probably doesn't work very well.
because the metal lines break when you roll it.
Yeah, exactly.
You need to protect what is for.
Yeah, sure.
It's more robust.
So what ports does it have? Does it have Ethernet built in? I mean, it has SDIO, I'm sure of that, because that's on the
on the
XScale.
motherboard. Anything that fits into 80 by 20, that belongs on a motherboard we've got. But that excludes Ethernet, USB, anything with a big connector. So all the connectors go on off-board, on the daughter cards.
Can they get all added to the motherboard?
project
Like
it.
if you wanted to get out a drill and add the USB and run wires?
You don't want to re-engineer the motherboard, and if you put that is so densely packed. If you put a drill not anywhere on it, it would be a lot of work to find a place to put a drill that wouldn't destroy the board.
Is it a multi-layer board?
Yeah.
8 layers.
I mean, hard to tell from the outside where
Where the stuff is on the
what's
inside.
actually free.
No, even if you're looking at that,
Well,
if you're
there's
looking at the
no-
Gerber, or you're looking at the layout drawing, there is nowhere.
Yeah.
And unless you have a, you know, 1/10 of a millimeter drill. I mean, really small drill.
Well, people do that to the open WRT, you know, they have USBs and all this other stuff. But
Yeah.
it's a much bigger board.
Yeah.
Remember, our form factor was chosen, and we put as much as we possibly could on that. And the limiting factor ends up being, can I squeeze another trace on there? And the answer is,
If you look at the
maybe.
surface of the board, there's
Yeah.
plenty of room for more chips, but you basically can't connect those chips to anything because the wires are all crossed, because the wires are so tightly
Well, other
packed
thing
on
is
the
if
board.
you can find where to put like the four, I don't know how many holes it would take to put a USB connector, but then you can run the wires, like separate wires and solder them to.
so, I suppose you could. If you basically, if you didn't drill it down, if you pasted it onto the gum sticks,
You could glue it maybe
yeah,
with the silicone.
and then connected a wire to the connector that's got the USB. I mean, we show you where the USB signals are to pull off.
Because I think some people might want a USB computer, they just stick the computer into their.
Oh, we have that too.
Oh, so we've got
We
that.
have a dollar card that does exactly.
It's a USB powered
It's this,
thumbsticks, yeah.
this thing.
You can make your own blacktop.
You talking about as device
Except
or
it's
as
a lot
host?
smaller.
Are you talking about as device or as a host at the moment?
That is a device.
So this is a dollar
So we're actually
card,
thinking of
and
making
the
that the
thumbstick
host
sits on
board,
top
too.
of this here. Actually, this works as a host board with our next generation gum sticks that has host
Yeah.
on it.
Well,
So
if you
the-
had one card for Ethernet and one for USB, that would be enough for me.
Actually, I think technically we can't call it host if it has this connector, because the USB spec says if you are a host, you must have a female connector. So the signaling is exactly the same, and you can just use a little gender changer,
Yeah.
and then it would be host.
But, and what about Ethernet? The Ethernet is on the CPU or something, and you
No,
just have to.
Ethernet is on a dollar card also, so if I go back
Hopefully not a
here.
60-pin one,
No, it's on a 92-pin one.
so that means you can have both.
So if you've been tracking the wiki, we will have a third connector, a flex connector on the next generation card, which has USB host on it. So you'll be able to have a 60-pin card, flex connector, and a 120-pin card on the back.
So are these stackable, like you could get the Ethernet with the MMC and then get the USB one and the GPS?
Yeah, so we basically, there are two connectors on the gum sticks. One is kind of a slow speed connector that has USB client, serial ports, SPI, I2C, kind of, up to sort of 20 megahertz-ish signaling.
So is that
And then on
USB
the other
one?
side, it's got a bus connector for the CPU, which runs up to 100 megahertz or 133 megahertz.
So we can't do USB 2?
It can do USB 2, but only at full speed.
Only full speed bus?
The USB goes up to full speed for USB 2 and high speed for 1.1, I think.
On the next gen, not on the current.
No, I
Yeah.
don't.
When is the next one coming out?
March something.
March-ish.
End of March-ish.
RSN.
What's-
Real
so
soon.
what's the
Yeah.
last-
Real soon, yeah, that's right.
This is the dual Ethernet. So we have $1 card for this.
So the deal with the next gen is that we've got OEM customers who are using it, it is designed in, but it's not ready for the hobbyists yet. There are just things we gotta iron out to make the transition easy for everybody. And
Yeah, so one of the paths that we are going is we're starting to add more what we call computers, where it's basically a set of boards together in a case. So this is one of our Ethernet boards. You can see the Ethernet jack. This has a gum sticks inside it. And it's, for people where you're not going to be soldering stuff, you just want, in this case, Ethernet and a compact flash slot. And this is power. And this little dimple here is actually just how the case snapped together. But basically, if what you want is just a computer and you're not going to be doing any hardware hacking, you just want to do software stuff on it, we're starting to add a lot more kind of packaged kits with a case on it for exactly that kind of function. So this is our first one of those. We'll be adding other ones over time.
Did I see one that had 2 RJ45?
Yes.
So you're trying to become like a firewall?
Yeah, so you can use it for a bunch of different things. You can use it for firewall, network monitoring, that's the dual one. Network monitoring, you can do traffic shaping. Yeah, if you added a Gumstix on here with another card on the other side, you could have something that's inline in the network and connected to a printer or whatever you might want to do. There's actually a company called, how do they spell it, ArcCO, that uses this, and then they put it in a case, and they're making a network security product that basically does all of, if not, or most of, if not all of the above. That animation is loose. That was pretty shady. All right, hang on, let me see if I can find the actual product. I mean, you'll recognize, there you go, you'll recognize the shape of this thing if you just looked at our dual Ethernet card. It's got 2 Ethernet ports, power on the side, and there's a Gumstix inside there, and they run Linux with some kind of, their custom traffic shaping application, and I think it basically does IDS, and if it recognizes a connection it doesn't like, it actively kills the TCP connections and injects reset packets and that kind of stuff.
Cool product.
Yeah, exactly. So, they built this product first, which is a 1U rack, it looks like 1U rack mount thing that has this software on it that does up to 1 gigabit. And then, they had a lot of their customers said, I don't actually have a 1 gigabit connection to the internet. So I don't really need this 1U giant thing. I'd much rather have something that, and I don't have any, by the way, I also don't have any rack space left. So, instead of a 1U thing, you can have what Gordon likes to call a 0U device that does the same thing.
Power over Ethernet?
This one actually has a little power socket in the side. We're looking at power over Ethernet for a next generation Ethernet board of some kind.
So you just plug that in like a filter?
Yeah, exactly. You just plug Ethernet in. You've got your internet link here. You plug this thing in, and then you've got your LAN over there, and it just acts as a filter.
And what's the power supply? I mean, like the common one is the Nokia cell phone power supply. I mean, they're all over the
Yeah, the one that we have is, it's not actually a Nokia. It's very simple.
Palm.
Oh, Palm used to use it. So it's just, it's fairly flexible. It's a little one of these connectors that it's like that, a little thinner. And it's anywhere from 4 volts to 6 volts or something. What's the range that we have to face?
Allowed range?
3.7 to 6.
Yeah, 3.7 to 5.5.
Yeah, it's like 1 watt.
So it can't quite make it to 3.3 then?
No, not quite.
The memory's 3.3. So.
Yeah.
Next gen won't be the problem.
What's the most memory you can get on these? The fastest CPU, the most memory.
400, currently 400 megahertz, 64 megs of RAM, 16 of flash is the highest. And our next gen
I was going to use this
600.
for compliance.
Yeah.
I want flexibility.
Right.
So can you talk about the booting process up until you jump into the kernel,
you've also got
the layout,
the storage
functionality?
That's what I was going to say. Is sure. You really don't even need that much flash if you just use it just to boot, and then you gain access to some kind of SD or MMC card.
Yeah.
He wants to use it as an appliance, but not necessarily go through U-boot in Linux. So wants to know what the alternatives are to using U-boot as the bootloader, I think, or what the layout of the flash is, so you can do whatever you want with it. Fair?
Right, and can I reflash it, on my premises?
Yeah, you can reflash anything you want on there. So if you get rid of the bootloader,
where is
there
it
are
on the flash?
It's on the flash. It's at sector 0, byte 0.
Oh, so the flash is formatted as
yeah. If you go to our wiki, it shows you what the flash map is. But basically, the first 256K are the bootloader, and then the rest is Linux. And it's just one big Linux file.
So I can just blow the flash away and do whatever I want?
Yeah, so if you blow away the bootloader, then you will need JTAG hardware system to get in there and actually do anything, because otherwise you'll power it on and it doesn't know what to do.
Right.
We have been selling a reflash service.
So
It has been
people do occasionally.
for us, because people love blowing away their,
Yeah, generally,
it happens a lot.
generally the bootloader is not all that big, and it gives you a lot of facilities for fixing things if you screw up the rest of your reflash. So generally, while you're doing development, I would suggest it'd be a better idea to boot into the bootloader first and have the bootloader load your, chain load your bootloader and execute that. Then once you've got it all, then you know it's all working, then replace the bootloader, because otherwise it's just more painful to have to fix it if you do it any other way.
The bootloader does have access to the MMC card and to the CF card
And
and to the
networking.
internet. So you can pull anything you want into the bootloader, or as the bootloader, as a chain bootloader.
So prior to executing the bootloader, there's some circuitry on that just jumps to it?
Nothing, yeah.
Just
The
start
CPU,
zero.
the first thing the CPU does, it reads whatever's at address 0 and then
Oh.
executes it.
And that's in the flash?
And that's in Flash. Address 0 is in Flash.
Okay.
And it's just addressable flash. So it just,
Right.
so what it does is it actually marches through from address 0,
Yeah, yeah.
and then it
So basically, the very
tells itself to
beginning,
load itself into RAM.
right, the very beginning of the bootloader just initializes the RAM controller, and then copies the bootloader and it just copies itself into RAM, so it'll run fast. The RAM's faster than the Flash, so it copies itself into RAM and then continues executing from RAM.
I see.
But the first 1,000 odd instructions, it's executing out of Flash.
And what is this JTAG device you talked about?
JTAG is it's a hardware debugging
Oh,
protocol for, basically there's some touch points on the surface of the gun sticks that you can connect wires to, that if you do blow away what's at address 0, it lets you basically control a CPU, so that when the CPU says read something from address 0, you can say, oh, don't use that address 0, here's what's in address 0. And you can actually just stuff values directly into the registers in the CPU.
JTAG is a standard thing that a lot of embedded systems have. Like if you screw up your firmware when you're uploading a custom Linux image to like your Wi-Fi router, like a lot of the Wi-Fi routers run Linux. Like you buy a Cisco or like a Lynx. Well, those motherboards in there, if you crack them open, have unsoldered points for JTAGs, and people sometimes, if they're constantly flashing, like hobbyists, they actually solder the JTAG connector to that, and then they have a JTAG cable, and you just attach it
to what?
To the JTAG connector, and then on the other end is an actual PC, and you use that to fix the.
Basically, what JTAG lets you do is you connect a JTAG cable to your device that you're debugging. The other end of the cable goes to your PC or your laptop or whatever. You run a piece of software on there, and it's basically like a debugger where you can just single step.
What's the electrical serial?
Yeah, it's a 5-wire, 6-wire thing. It's got a clock and a.
Well, what I'm asking is, what do you?
Basically, you just say TDI goes to TDI. It's another software deal.
My question is, what hardware do you need on the PC side? Anything extra?
Yeah, so there is a device called a Wiggler. You need something that is a Wiggler or Wiggler work-alike, which there are schematics that you can get on the internet, and it's like $10 a parts at Radio Shack.
Or it was $100 from McGregor.
$100 to get a prefabricated one from McGregor, I think is the company that makes them.
I don't think they claim to support the parallel port version, though, where they want you to take the USB.
They want the USB one, which costs $200 instead or something.
Significantly more.
Oh, really?
If you go on eBay and put in JTAG, you'll find like people selling those cables for like $5 or whatever.
Yeah.
Or Wiggler. The one we chose, and we use the WIGG really, or the Wiggler.
Which is the parallel form.
Yeah.
From something called.
Which is somehow better than JTAG?
It implements JTAG. It's the PC side of JTAG. It's basically how do you get the JTAG signals into your PC so your PC can control the lines.
I was
And the answer is
USB.
You can do it through USB too. The USB is more expensive.
There's more than one way to do it.
Yeah.
Sure.
Basically, what we're talking about.
Please. Can you explain a little more? From the cards that are already available on the product, what are some of the solutions that I should look at for controlling relays and outputs?
The Robo-6. So the nice thing about the Robo-6 exists to be blown away. It's a $39 part, and you can plop down a gum sticks to it, and then use. So I think that electronically it is not perfect, but it's pretty good. And you can connect to the A to B's and timers and PWMs and everything using the Atmega.
Okay.
And then if you blow it away, it's not, you can just go get a $39 board and replace it.
Okay, yeah, that's where I kind of ran it when I was trying to, navigate the website.
Right.
I said, well, gee, I guess that the kind of things I wanted might be over there.
If you want to know more detail and get a really good set of answers, the Gumsticks users mailing list, if you go to our website and look for the mailing list information, just ask the question on the mailing list, and we have, so Gordon and I don't actually, the Robo-Sticks is a product that we don't actually know a whole lot about. One of our users basically said, I really like this thing, and here's kind of a rough idea for the design, and we worked with him and kind of did the design and built the thing. And
Revit on the, so.
Yeah, I mean, we've basically never used it between the two of us.
Yeah.
It was basically something one of our customers wanted. Everybody else, all of our other robotics customers said, yeah, that'd be a good idea. So we built it, and they seem to love it.
Yeah, they maintain it.
They maintain it, and, but they're very.
You wrote one bit once. You changed one bit, and you moved in order to accommodate Robo-Sticks.
Yeah.
But other than that, it's entirely user maintained.
And but having said that, it's very actively maintained. The people who use it, they're probably 5 or 6, 7 messages a day on our mailing list about Robo-Sticks from people asking each other questions and answering them and sharing bits of code and how do I connect it to this kind of a controller, or use it with this kind of stepper motor or whatever, and they're going back and forth all the time.
Yeah.
I just say mark as read file. I get to go with them.
Do you have anybody trying to run, real-time operating systems on them, like the Ecosys?
People have asked from time to time. I merged in the real-time extensions to the Linux kernel recently, and that seemed to satisfy most of the people who wanted more real-time-y stuff, lower latency stuff. Yeah, exactly. It depends on what you're doing.
Software controlled radio is not in the domain.
Right, exactly. So, generally, I think if what you want to do is hard real-time stuff with really low latencies, a lot of the time, a real-time operating system is not actually going to get you all that much better than Linux. I mean, it will get you a hard limit on whatever the latency is, but the latency will be so big that you might as well go with the real-time Linux stuff.
Well, it depends on what you're doing.
It does. But so what I was going to say is the alternative is you can actually take U-Boot, which is a bootloader, which kind of provides a rudimentary operating system in that it provides drivers basically for various bits of hardware like the Ethernet and whatever. And most of the time you want kind of one thing where you're processing things with hard real-time constraints, and everything else is basically shut off while you're reading, taking samples from your data logger or something. And then after you've been collecting samples for a while, you'll say, okay, now I've collected all this stuff in my 64 megabytes of RAM. Now I'll turn around and upload it all, stop collecting data, upload it, and then go back to collecting data with interrupts turned off.
Of course, another way to look at it is to use your RoboStick system and have the Atmega be your real-time.
Yeah, or hang a pick off it and have the pick do the real-time stuff, and then every so often upload stuff through a serial port.
Rather AVR myself.
whatever is more useful for whatever the actual domain application is.
The fish uses picks, I think.
Yeah, I think the fish has 3 picks controlling reading from the sensors.
Yeah.
I saw something in the prop CPU info, I guess that's what it was, where it's talking about I's and D's. Does that mean this thing has a Harvard architecture or something?
Yeah.
It does?
Yeah, it has two 32K caches, 32K each of instruction and data cache.
I haven't noticed that before.
And actually the new one has, I think the 270 has, it may still be 32K each of instruction data. It may have gone up to 64, but then it also has 128K of SRAM on the CPU. So you can put stuff in there too.
I keep thinking that it'd be fun to have a DRAM-less or SDRAM-less gum sticks with 2 mega flash and just the PXA 270 on it as a really low end, but pretty powerful.
To replace the RoboSticks.
To replace RoboSticks. We don't have the A to D on it, but exactly to get into that somehow. Do you
Just
think
get a
it's
little, get a $2 A to D thing hanging off the I2C
Yeah.
or SPI or something.
Exactly. Well, thank you very
Any other
much.
questions?
Anything else?
Yeah.
Thank you.
If you have any other questions, go to our website. You can ask on the Gumsticks users mailing list, or our email addresses are probably there too, or you can find them in the mailing list archives. Just
People
ask
think
anything you want.
Cisco platforms and
Happy to answer.
Yeah,
they're so much cheaper.